Reda Sarj Max. Hasib record internal and external forces. External forces are influences from outside a system, like gravity and air resistance, while internal forces come from within, such as pushing and pulling. Newton's laws of motion explain these concepts. The law of inertia states that objects maintain their motion state unless acted upon by an unbalanced external force. The law of acceleration describes how an object's acceleration is proportional to the force applied and inversely proportional to its mass. The law of action-reaction states that for every action, there is an equal and opposite reaction. Levers are categorized into three classes based on the positions of the fulcrum, applied force, and load. First-class levers, like seesaws, have the fulcrum between the force and load. Second-class levers, such as wheelbarrows, have the load between the fulcrum and force. Third-class levers, like tweezers, position the force between the fulcrum and load. Linear motion is movement in a straight line, while angular motion involves rotation around an axis. Linear motion can be constant or accelerated, while angular motion involves concepts like angular displacement, velocity, and moment of inertia. Torque, the rotational equivalent of force, combines force and lever arm distance. Ergonomics is the science of designing workspaces and products to suit users' physical and cognitive needs, thereby enhancing comfort and efficiency. It uses biomechanics to design workplace equipment, like ergonomic keyboards and adjustable chairs, to minimize fatigue and discomfort, and to create devices like orthotics for correcting physical issues. Biomechanics for injury prevention and rehabilitation focuses on understanding bodily movements to prevent and rehabilitate injuries. For example, training programs are designed for female athletes to adjust landing postures, reducing ACL injuries. Static and dynamic systems in biomechanics involve two main types: static systems, non-moving like a gymnast holding a pose, and dynamic systems, changing movements like a diver in motion. These systems are analyzed under the 7 principles of biomechanics, which include stability, maximum effort, linear motion, and angular motion. Stability in biomechanics depends on factors like mass, center of mass, base of support, and the position of the center of mass. These principles are applied in various activities to maintain balance and stability. Production of maximum force involves joint rotation and muscle contraction. It's essential in sports and activities where proper joint movement and muscle contractions are necessary for effective performance. Sequencing of joint rotation is crucial for efficient movement. It ensures that larger, slower joints start the movement, followed by smaller joints, as seen in sports like baseball or activities like fly fishing. The impulse-momentum relationship explains how the application of force over time affects an object's motion. It's particularly relevant in sports, where players control the impulse applied to change a ball's momentum. The effect of a force acting at some distance from an axis deals with torque and its role in producing angular motion. The magnitude of torque depends on factors like the force's magnitude, lever arm length, and the angle of force application. The conservation of angular momentum is essential in sports like gymnastics and diving. Athletes control rotation by manipulating their moment of inertia, with the total angular momentum remaining constant if no external torque acts on the body. Angular momentum. This is the product of an object's angular velocity, rate of rotation, and its moment of inertia, resistance to angular motion. The moment of inertia depends on how the body's mass is distributed relative to the axis of rotation. Manipulating moment of inertia. Athletes can control their spin speed by changing their body configuration. For example, a trampolinist or diver might tuck their limbs close to their body to spin faster, which lowers their moment of inertia. Conversely, they can extend their limbs to slow down their spin, increasing their moment of inertia. Law of conservation of angular momentum. This law states that if no external torque acts on a body, its total angular momentum remains constant. Therefore, when an athlete changes their moment of inertia, like going from an extended position to a tuck, their angular velocity increases or decreases correspondingly to conserve the total angular momentum. By manipulating their moment of inertia, Athletes in rotational sports can effectively control their spin and rotation, which is crucial for performance and safety in these activities.